Well, good morning, and for some of us, good afternoon. Welcome once again to Beyond Compliance. My name is Aaron Bolshaw. I'm the moderator of Beyond Compliance. For those that may be joining us for the first time, you've not been around Beyond Compliance yet, it's a periodic industry update for process manufacturers. Our goal, pretty simple, just to bring you insights from around the market that shape the way we grow our businesses, deliver quality products to customers, mitigate some supply chain risks, and also safeguard our brands, all while, of course, improving yields, maximizing productivity, because that's what it really counts. And this is going to be a fun one today. So we're getting into the real cost of quality, understanding that it's probably a little bit more than what you think it is now. And most of us are probably doing something to measure cost of quality, but we're going to go through some methods, models, and tips today. So really quick before we go further, SafetyChain is the #1 plant management platform uniting compliance, safety, quality, and production. And so with that, I just want to get into very quickly setting the table. We aren't able to hear you as the speakers and moderators. However, we do want to hear from you. So as we go through our presentation, if you have any questions, use the webinar console on the right side of your screen, or should be on the right side of your screen anyway, to submit questions. And we'll save time at the end to get through as many of those as we can. We are scheduled for about an hour today. We're going to be flexible with our time. If we can wrap up early, we're going to give you some time back and we'll go on our merry ways. However, the answer to most people's favorite question is this: yes, you will get the slides, you will get the recording after this webinar concludes. So, okay, well, with that, I do want to introduce our speaker today, Dennis DeVos. And he has probably been in a few of your plants. I'm just guessing, but he's a fellow for the American Society for Quality, ASQ, as we affectionately call it, of course. And he's a leading authority on quality management, lean methods, auditing, and of course, cost of quality. He's authored and contributed to books on auditing. I think it's the ASQ Certified Quality Auditor Handbook and the ASQ Certified Quality Manager Handbook. So both very enlightening, and he's bringing all that to us today. Also engineer at General Motors and the automotive industry, has deep expertise there as well. And of course, training and advisory services for many other manufacturing sectors. Welcome, Dennis.
Thank you very much, Aaron. I hope everyone can hear me. Welcome. And thank you for coming to our presentation today. It's wonderful to be back, and I'm so excited to be able to talk to you a little bit today about our true costs for quality.
Yes, and I do hear we're a little bit of audio connection issues. If I keep hearing them, Dennis, we'll let you know. But we do hear you loud and clear, and we're happy you joined us. We've talked about this ourselves, Dennis. The way that people actually measure the cost of quality is it can vary a lot, and for a lot of different reasons, right? There's going to be some facilities that sort of say, hey, I want to measure it this one particular way because of this one particular situation or scenario, because of our product process to our customers. But we're here to kind of open up, I think, the blinds a little bit to some other bigger pieces that go into the cost of quality. So before we get into that, can you tell us a little bit about your practice and what you bring to the table for your clients?
Well, thank you. As you said, I have a background in the automotive industry, but of course, if you're familiar with lean manufacturing and a lot of these other concepts, they had their origins in the automotive industry. So that's what we do. And we have a lot of clients across different sectors, food and beverage, for example. And a lot of packaging is really just, plastics, blow molding, and plastic. A lot of folks want us to talk to them and help them implement some of the leading practices that we use in the automotive industry.
Yeah, it is true. The automotive industry has led the way for a lot of discrete manufacturing, but now we see a lot of process manufacturers take up those same practices, especially around Lean, Six Sigma, Kaizen events, things like this that really do help overall productivity, because that's kind of what we're in the game for, right? So, well, let's. I'm going to hand this over to you. Why don't you take us through what we're trying to accomplish with our time today with our
Great, thank you. So we're going to take you through the cost of quality model. A lot of you have probably already seen this and have a familiarity with it, but we're going to remind you about traditional cost of quality model. We're going to talk a little bit more about capturing the true costs of poor quality, and I'll talk to you about opportunity cost. A lot of times people make the mistake of thinking that the cost, for example, if they have a bad batch and they have to scrap some product, they often make the mistake of thinking that the value of that material is the scrap value, or maybe even the cost of making that material. But I'm going to talk to you about how a more realistic picture is to consider the cost of the cost of what you are scrapping at the retail sale price. We're going to talk about opportunity cost. If you are making bad product, you're not making good product, and you have an opportunity, right, for every pound of bad product you make to have made a pound of good product. We'll talk about failures, eroding production capacity, and the cost of quality is a great aggregate measure for an operation like OEE, for example. The cost of poor quality, and it really, I'm going to talk about how it really starts to matter when you're full. If you're not running at capacity and you have to do a little bit of rework or you have to remake a batch, that's not the end of the world because you have room to do that. But if your plant is running at full capacity, every little hiccup, every little bit now that you have to rework or remake really hurts because it cuts into the capacity for real product that you would sell at retail price. We're going to be talking about that and making sure that we understand those costs and can factor those in to the true cost of quality. We'll talk a little bit about some tips, and then I have a couple of examples at the end, real world examples to take you through as we go. So we can get started. The definition of, or one definition of the cost of quality is a method for determining the costs incurred to ensure quality. Now, you may know that there are two halves, if you will, to the cost of quality model. There's the cost of poor quality, the internal failure costs such as scrap and rework, the external failure costs, warranty, etc. And then we have costs, costs of good quality. The money we spend sort of as an investment for quality assurance. So we have costs to prevent non-conformance, and we have costs of inspection and test, appraisal costs. So we spend money, think of it like insurance, to assure quality. That's an investment, we hope. Then on the other side, we have the cost of failure, customer complaints, et cetera, et cetera. Oops. So examples of non-conformance costs, again, external failure, warranty, sorting material at your customers, et cetera. Internal failures, right? We haven't shipped bad product, but maybe we identified some scrap, rework, et cetera, inside of our own plant. And those costs are costs of failure, costs of poor quality, if you will. On the other side, the conformance costs, the money we spend to assure quality. Routine inspection, testing, auditing, money we spend to catch problems before they get out. Prevention costs, we really want to invest everything we can in preventing non-conformance. Tools like HACCP, FMEA, et cetera, help us with that. Investments we make in worker training, automation, myriad different ways of investing in our processes to assure good quality the first time. You've probably seen this before, the iceberg. You know, a lot of us look at costs that are maybe just above the waterline, the part of the iceberg that we see. Most people who get involved in tracking the cost of quality are good at tracking those visible costs: recalls, returns, reworks, rejects, waste in various forms. And those could make up, 5% to 30% of sales, depending where you're at. But I want to talk to you today about some of those hidden costs. Look under the waterline. If you're busy and you have to remake an order, you're probably doing it on overtime. That's an added cost. Paperwork, excess inventory, premium freight, expediting, remade batches to your customers. Unused capacity, customer allowances, giving your customers rebates or concessions to get them to buy your product that's a little bit off spec. Billing errors, complaint handling, overdue receivables because they're not going to pay you right away, customer dissatisfaction. Some of these costs can be elusive, but they're really the right things to try to track. Again, some examples of external failure costs: warranty, sorting, remaking an order that was rejected by a customer. How about breaking into the schedule to remake? If you set a schedule for several days and you suddenly have to break in to remake an order, that's hugely disruptive. What's the impact of that in your organization? You may have travel costs to the customer, to the field. Those costs become a cost of external failure. Customer grief, loss of reputation, hard to quantify, but very, very important. Internal failure costs, of course, scrap and rework, repair, remakes. Breaking into the schedule to remake is the very same thing, whether we catch a problem inside the walls or outside. Changing your schedule, retooling, setups, cleaning out your vessels to change over, right? When you're breaking in like that, hugely disruptive. Downtime is sometimes considered a cost of poor quality. Taking a markdown for concession, expediting raw materials because you used everything up and you need more, etc. The conformance costs are those investments that we make to assure product quality. Prevention costs, some examples could be our design choices, design for manufacturability. The bill of material for our product might be a little bit more expensive because we know that choosing those ingredients or those components make the product easier to make and leads to overall lower cost, less risk in manufacturing, etc. FMEA analysis, HACCP, is an investment in prevention of non-conformance. Error proofing and automation. Training, a lot of people don't think of training as an investment in quality, but it certainly can be. Quality management systems, auditing at all levels. So these are costs, absolutely, they're not free, but we hope that those investments help us to assure good quality. Appraisal costs on the right, inspection and test at all levels. Receiving inspection, purchasing inspection, measuring and test equipment, maintenance and calibration, labor, etc., etc. So the full cost of quality model does include both the prevention costs and the appraisal costs. A lot of us, though, nowadays tend to focus on the cost of non-conformance, the cost of poor quality, but understand that the complete model includes those investments in prevention. I don't have to tell you how expensive it can be when we screw up, right? One bad batch is too many. Depending on the sector you're in and depending on the customers you serve, when your customers receive defective materials, they may impose penalties on you. They expect us to perform a full investigation of root cause and implement system-level corrective action. They expect us to spend whatever it takes to fix the problem to make sure it doesn't come back. Containment, or in some industries, it's called controlled shipping. Your customer says, you know, you sent us this defect. Now we don't have confidence that you're going to keep providing us quality product. We want 100% inspection until you can prove to us that we're no longer going to get defective product. In some industries, we have third-party containment. Not only do you check your output 100%, then an outside company does it again at your expense. And the example I have on the screen is typical. $30 an hour for a sorting company, 3 people, 2 shifts a day, 20 days a month. The cost of that containment activity can be $30,000 or more per month. When we recognize that the cost of poor quality is very high, in the way I've just described, that compels us now to make investments. Investments in prevention, appraisal, to really make sure that nothing bad gets to the customer, because as we said, one bad batch is too many. Now, there are costs to investing in quality assurance. There are costs associated with correcting mistakes. But you may already be thinking that, well, how much is too much? How much could one invest in preventing defects? And you might be overspending. So I'm not going to take you through this curve, but you can see that when I have poor quality, I have a very high cost of non-conformance. Maybe when I have exceptional quality, I have no defects, but I've really made high dollar investments in that quality assurance. So I've been spending money either to prevent non-conformance or to fix it. So what we do is we encourage you to look at where these two curves cross and choose that optimal amount of spending when you invest in quality based on the cost of your non-conformance. If the cost of your non-conformance is low and your customers aren't imposing crushing sanction on you, it might make sense from a business perspective to spend less on prevention and just pay to fix the mistakes and the bad product that gets to the field. That's a business decision to make. So again, you heard me say that investments in appraisal and in prevention are like insurance. Right? We invest appropriately in prevention and appraisal methods to mitigate the risk based on how high the cost of external failure is. Now, if you look at your HACCP and your control plan, look at the cost of all of those controls and look at the cost of those inspections. Add that up. What does it cost you every year to assure good quality? That's your prevention cost. That's really, think of it like an insurance premium. If you spend $1 million a year on quality assurance, well, you hope that you're avoiding $1 million a year in penalty. If you're not, you might be overspending on the prevention side. If the cost of non-conformance is $100,000 a year, spending $1 million to avoid that may not be the best business choice. The cost of poor quality comes right off the bottom line. It's free money. So we have to think now about what is our annual cost of poor quality. Add up the costs of replacement orders, remaking orders, expedites, sorting, travel, containment costs. Add up those costs of poor quality, and now that becomes a bag of free money that you have to potentially save, and you can use that money that you save on external failure to invest in prevention. So we think about it like free money to be used elsewhere. Like I started to say, you can add up the costs of your automation control and inspections and decide if those investments you've made in risk reduction cost or pay. Is the investment that you make through your FMEA and your HACCP an asset or a liability? What is the true cost of your controls, and is it worth it? We hope that it will cost less to avoid more. So you have to first understand what those costs of external failure can be. What is the cost of poor quality in your industry and at your customers? That's the bogey, and we invest up to that amount to avoid those costs. In a HACCP or an FMEA, we talk about the probability of occurrence of a failure. Those occurrence rankings speak to how often or our level of internal failure. The detection scores speak to how well will we contain the problem in our own plant, or will it get out the door to our customers, resulting in an external failure. And we know that the cost of external failure can be a lot more than the cost of internal failure. So set those targets for yourself. What do you want your cost of external failure to be? And then use your control plan to drive that cost of poor quality down and meet those targets by making targeted investments in your appraisal and in your prevention. I want to talk a little bit about opportunity costs. And this is really, I think, where you'll be deriving the value from this morning's presentation. The opportunity cost is the loss of some potential gain from other alternatives when one alternative is chosen, right? So what else could you have been doing with your people while you were doing rework? Well, you probably could have been making good product. How much profit could you have earned using that time, using that machine capacity, if you were building good products to sell instead of building stuff that you were throwing in the scrap bin? Opportunity. Using 1 hour of machine time to generate scrap is 1 hour of machine time you could have been making products to sell at full price. That's the opportunity cost. I call the cost of poor quality the capacity killer. If you're not very busy and you have to remake an order, you have to do a little bit of rework, who cares? You have lots of time and lots of machine capacity to do these things. The impact on your organization is, well, it's not negligible, but it's not a crisis. You can have rework, repair, rerun. And if you have time to do that, you're never late to your customers. But those true costs and impacts get masked by all the free capacity. Right? You don't recognize how that is eroding your productive capacity, because for all of those things that you're doing wrong, you could have been spending that time doing it right. If you're full, defects, rework, reruns will kill you. The true cost of every part you throw away is not the cost of the materials in that product, it's the full selling price. You can never get that time back again. If you're full, now you're doing rework and reruns on overtime. So what's the cost of bringing in labor at time and a half, bringing in supervision, planning for overtime, maintenance support, and probably worse even than that, when you're making orders twice, now your customer orders back up and lead times get longer, leading to further customer dissatisfaction. I have clients, you know, that extrude aluminum or they mold plastic. And a very common thing that you hear is, well, scrap isn't a problem, right? We just remelt the aluminum or regrind the plastic. We reuse the material, right? We've lost almost nothing. I hear this a lot, and it makes the hair on the back of my neck stand up. It's just not right. Or how about, you know, we pay our employees anyway, so we just have them sort parts, you know, they're already on the payroll. Doesn't cost us anything. What could they have been doing instead? Here's a quick example from a little game that I play on my phone. In this little game I play on my phone, I can bet $1 to get 3 gems, and I have a 100% success rate. Now, I can also bet that same $1 to get 4 gems, but I may only win 4 gems half the time. It makes more sense to constantly bet $1 for 3 gems rather than risking trying to get 4 and getting 0. So every time I bet on the 4 gems and it fails, I could have had 3. Now I have to win the 4 gem bet. Say that 3 times fast. I have to win the 4 gem bet over the 3 more times just to break even. Because now, right, the net gain is only 1 gem. Every time I lose, I now have to bet again to get 4 to make up the 1. So I've got to play 3 more times. I have to succeed 3 more times just to break even. Another one I was thinking about the other day. There's a cheap gas station about 20 minutes out of town. And you would ask yourself, well, is it worth driving 20 minutes to get some cheaper gas? Well, I can save about $6 a tank on gas. So that's okay. I drive 20 minutes back and forth. So 40 minutes I invest. So I can save $18 an hour getting cheap gas. Now that's not bad. But in my line of work, I need to be billable. Could I be doing client work? If I could spend that hour doing client work while I earn more than $18 an hour, it doesn't pay to spend my time running around for cheap gas when I could sell that time for more. But I'm not that busy. I'm not working on a Saturday. So I can drive for cheap gas on Saturday all day long and save $18 an hour. Because the value of that time on a Saturday that I can't sell is 0. So there's lots of examples, but we have to think in those terms. The cost of poor quality includes what could I have been doing instead? I'm not an accountant, I'm an engineer. When you say, what's the value of a half-built house? The accountants would say, well, there's a certain amount of lumber in there, there's a certain amount of labor in there, and they would give you some value. Now, of course, I can't hear you, but I want all of you to say it with me together. What is the value of a half-built house? Nothing. The value of a half-built house is nothing. The accountants can value the materials, etc., etc. They're just simply wrong. No one will buy a half-built house. It's worth nothing. It's worth negative because you have to pay somebody to tear it down and haul it away. Those sunk costs are gone. A half-built house has no value. Everything in it is spent. You've thrown away whatever, $50,000 in a half-built house, and as long as it's a half-built house, it's worth zero. It's true. Not everyone thinks of that this way. So if you use an old accounting model for your cost of poor quality that somehow gives you this voodoo value of a half-built house, it's not true. It's not real. The value of a half-built house is nothing. It's worth nothing until you build it and sell it. All right, what else? So a little bit on the approach to reducing your cost of poor quality. So first, identify those opportunities for cost reduction. High scrap, high rework. Quantify the true cost of the problem. And that quantification should include opportunity cost. In a few minutes, I'm going to show you that most people really underestimate the true cost of poor quality. So where do you think you can make some gains? What are the true costs of the problems? And then you have that target, that bucket of free money I talked about. And that can help steer us in terms of how much we're willing to invest to solve the problem. Then, of course, like any type of problem solving, we prioritize those actions that we can take to improve the process to reduce the cost of poor quality. Prioritize the actions, take the actions, then evaluate your success as cost reduction. Maybe the cost of your problem was $100,000. You invest $10,000 to make some improvement. Go back now and reevaluate the cost of poor quality. We hope it came down. Maybe it came down to 50. That's a huge gain. You reduced the cost of poor quality from $100,000 to $50,000 by spending $10,000. That's a pretty wise investment. So we evaluate that success in dollar terms. And then, of course, sustain the new practice, continuously improve, work at knocking that cost down even further. Without getting too much into the weeds, you know, we can identify our problems. We can identify those high cost problems based on some Pareto chart or based on some prioritization matrix, a 2x2, which would weigh, you know, effort and cost against benefit and value, and deciding which one or two projects are most important to begin first. I have a couple of examples to share. And although I've played with the numbers just a little bit for illustration purposes, these are actually real examples. I didn't make them up. I had a client that was in plastic extrusion, and they were sort of a job shop. They weren't very big. And they had many customers, and they did a wide variety of plastic products, some automotive, and some of their parts were painted in-house. And they had a level of customer rejections and internal rejections, which meant that they had to remake batches of their plastic products, you know, 3 times a month or 4 times a month. They had rework of molding defects and paint defects at a level of about 2.5%. And I remember this case because I was going through with them, you know, their management review, et cetera, and they were showing me their cost of poor quality. And they thought it was $300 a month. And just sort of in my head, I knew that given the scenario I just shared with you, it's impossible for it to be that low. And of course, the plant was at full capacity with a customer backlog. So I worked with this client, just did a little bit of back of the envelope calculation with them. And we can use this example. If I made 720 pieces of this plastic extrusion, now I have to rerun an order for 720 pieces. The cycle time is 3 parts per minute over 4 hours, etc. Now there's a machine charge time. Our machine charge out time is $600 an hour. We need to add an hour for setup, so that's 5 hours. Labor, of course, the rerun had to be done on the weekend. We needed 1.5 operators at $30 an hour. We had cost of additional inspection and packaging. The parts sell for $2.10. So that's the value that we lost by rerunning this order. Not the 20 cents or whatever worth of plastic that's in it. So the true cost of poor quality for one run is 5 hours at $600 per machine hour, $3,000. Labor, inspection, and packaging, 180 plus 250, and then the cost of the lost sales. And some people will disagree that that value whether or not that value belongs in there. I think it does, for the reasons I just described to you. Opportunity cost. I'm throwing away all of the value of the good parts I could have made when I made that order. So when you add it up, it's of the order of $4,870 per run. That's already a lot more than $300 a month. That doesn't include even some indirect labor, like weekend supervision, support, other sort of administrative penalties that are imposed by the customer. We had to probably do some type of, corrective action form with them, maybe be on the phone with them. Those are all costs. Maybe there's travel to the customer. Our salesmen or our quality folks had to go out and visit the customer to try to placate them. All of the associated indirect staff time, credits, RMA, the cost of cutting into an already full schedule, the cost of customer annoyance. And then again, this is just back of the envelope sort of stuff. If $4,870 is sort of an average cost for a rerun, if you're going to do 4 a month, maybe 3 or 4 a month, that's about 48 per year. Add all that up, $230,000 a year, not $3,600. And I don't remember where they got that $300 a month value from, but this is the truer cost of quality in that organization. So of course, when I did this with them, just quick, and of course the president of the company who was in the room, his jaw dropped, and as well it should. When you calculate the true cost of poor quality, rolling in opportunity costs, you're often very surprised and very shocked. And that then creates the impetus for us to improve. It's not a few $1,000s a year. 200 grand is starting to be real money. Another quick example, maybe I make 5,000 orders a year. Maybe I have 2% rework. And that's conservative, but that's a realistic number. That's 100 reworks per year, right? 2% of 5,000. I have to inspect and reject the original lot. Maybe that's $30 worth of labor. I prepare a rework ticket. I rework the product, 2 people on a weekend. Again, when you're full, all of this is done on overtime. If you have the luxury of just bringing in some folks on overtime, for various reasons, you can't even always do that. Moving material, repackaging the parts, re-inspecting the lot. So in this quick example, 2% rework, which is conservative, 100 rework activities a year starts to cost you now $73,000. right off the bottom line. Free money. Right? Every single time that you can avoid rework, make one less defective batch, you're putting more money in the bank. How bad can it get? You've heard of these two companies, I'm sure. Takata is a recent example, just from a few years ago. They were the world's largest automotive airbag manufacturer. And they had a recall across something like 42 million cars because they made seatbelts for everyone. By the time the fines and the payouts were made, the company went bankrupt and it was sold off in pieces to its competitors. The value of that company used to be 400 billion yen. It's a Japanese company. When they sold it off in pieces, it was worth, what's that, 1 cent on the dollar? 4 billion yen. That's the cost of poor quality. A leading global automotive supplier driven out of business. Union Carbide. This one goes back a ways. I can't remember. I want to say 20 years ago. Union Carbide had a plant in Bhopal, India, and the plant exploded. And it was, I think it was a fertilizer plant. So when the plant exploded, had this fire, there were massive toxic clouds, and something like 10,000 people died from breathing in this toxic gas. It might have been chlorine, I don't remember. $470 million US in damages. And the CEO, he ran away. I don't remember if they caught him or not, but he ran, and the CEO became a fugitive because he faced such personal liability and jail time. Of course, these are, thankfully, special and rare examples, but this is how bad it can get. So understand the cost of poor quality, the true cost of poor quality, understand the investments that we can make to avoid those costs, and you will avoid these penalties. I think this is the last slide. I wanted to just share with you there a textbook written by my good friend Doug Wood at ASQ. And there's a book called The Principles of Quality Costs that goes into a lot of this type of topic if you're interested. So, in summary, the true cost of poor quality can be shocking, and it should be. It really should hit you right between the eyes. If the cost of poor quality is too low, you're not going to do anything about it, let's face it. The real cost is using productive assets to make scrap and to make orders twice. Loss of profit, loss of reputation. The customers now aren't happy because they can't use what you gave them, and now they've got to wait until you can give them more. Identify those high cost areas, select a project with high payoff, and work on process improvement. And then evaluate your success by using the same cost of quality model and see what you saved in terms of your external failure costs by making those investments. And the cost of quality, or the cost of poor quality, is and should be an important key performance indicators for all organizations. And if you're not already tracking cost of poor quality as an important KPI, we certainly do encourage you to do so. Time is money. And with that, I think we'll conclude our presentation. Thank you for listening. And now I will invite Aaron to share questions with me, and I will do my best to answer those for you.
Oh, very good. Yeah, time is indeed money. I think everyone on this phone call knows that very well. It's the ability to translate that into real financial terms and then sharing it with finance so that you get resources that you need. So you get the attention and the the wherewithal to actually make improvements. I think I speak for some of SafetyChain clients where we say, there's a real gap in some plants' ability to move from, I got this data, I understand there may be a problem or there could be a opportunity to improve, but I don't know how to get people in a better understanding of it, right? And that's indeed the trick. So
Absolutely.
I've got a couple of questions. I encourage anyone, if you have any questions, please use that console to your right. Send them in. We've got just a couple of minutes here to go, but Francis asked, well, it's kind of a bit of a story. I'll kind of work my way through it, Dennis, and give you this as a bit of a synopsis. So there can be a lot to track to get full accurate COQ. What are the one or two best practices to produce this? And he so it was two questions. Both the other question was, do I want to produce a good quality number and a poor quality number separate and then look at them that way?
Let me answer the last question first. The answer to that is yes. You do want to track appraisal costs or prevention and appraisal, right? The cost of good quality separately from the cost of failure. And here's why. Of course, you can't see me because I'm not on video, but I'm talking with my hands. You're going to have two curves. And the two, it's not really the one in the presentation. Well,
No.
it could be that one, but if you think about it, if I have a high cost of poor quality and I'm making improvements, I want to track that over time and I want to watch it decline. I may have a cost of internal quality or a cost of good quality, if you will. That line should stay constant or maybe increase just a little bit. Once you see the two lines cross, then maybe you're spending too much on the good quality, right? The other reason you track them separately is because the, how do I want to say this? The initiatives, if you will, or the ways of addressing and reducing the cost of internal quality assurance and external failure are different, right? So there's sort of different metrics that mean sort of different things, and your approach when you try to work on one or the other are a little bit different. So I would encourage you to split them up. If you think about it, if you have them as an aggregate together, your cost of quality line could be dead flat. But underneath of that, what you might not see is that your external failure costs are going down, your internal prevention costs are going up, so that the net value looks like it's the same, right? The components, the two halves that contribute to that change. And you could say, oh, well, our cost of quality number hasn't moved in years. That might be true when you add them together, but it could be that you've really made a great increase in reducing the cost of external failure by making internal investment. If you keep the numbers together, you won't see that. So hopefully that makes sense. The first part of the, sorry, Aaron, were you going to say something?
No, I said that's awesome. That's exactly right. So the key is separate them both and know, hey, if that line that you're talking about for poor quality hits that good quality, then you have a moment to think and say, wait a second, maybe we need to readjust.
Yeah. And the first part of that question is about like best practice. How do you choose the numbers that go in there. And I'm just going to point back to the example I had. It could be either one of these. They're similar, but think of something like this, right? So if the question was, what do you include in the cost of poor quality? It would be something like what I have on the screen. It would be the cost of rerunning the product, thinking about labor, thinking about machine time. It would be the cost of the material that you scrapped at full retail price. That's the opportunity cost. So some of what I have here on the screen, I would use as the answer to that question.
That's great.
Now, let me say at this point, because I didn't say it in the presentation, how you measure the cost of poor quality is less important than always doing it the same way. Create a model, and the model will be imperfect. That's fine. The key would then be to measure cost of poor quality consistently, so that if you have an imperfect model, but it's repeatable, you'll be able to compare your performance over time. If you are constantly changing your cost of quality calculations, there's no way to compare your performance, right?
It also becomes less believable by those in finance, right? So I like your thought there, Dennis, about the model. Models are made to be broken. They're made to learn from what's actually going on the floor, right? And adjust as needed because things change, right? So I like that model building. And then what you can do is you can kind of shake a stick at the math and go, well, this is what it's saying. This leads us to a great question, Dennis. The next question here from Amir was, thanks for the presentation, great stuff. To gather those costs, where is it better to start? Is it accounting department or doing some time studies on the floor and actually gathering the data yourself? That's a really great question.
It is a good question. And of course, as an engineer, I used to sort of, discount the value of the accounting and financial folks. But the answer is it's sort of both. But engage the financial people. Now, recognize that they still believe there's some value to a half-built house, but that's okay. We love them anyway. That's all right. But I found it useful to take the models that and every time I work with a client on this, the models are slightly different. And that's okay. Again, consistency matters. But anyway, then reality check your model with the financial people. That's always worth doing. Make sure that, because we're not financial experts, but say, hey, Mr. Finance, we think this is kind of the cost of poor quality, and walk them through your model and see what they think. And they'll usually have something maybe to contribute, but they'll always agree. If you do this properly, they're never going to disagree. And that's good. It helps to get their feedback to reality check your model. It helps engage them. And a lot of the information that you need for your model, you will probably need to get from that department. So you want to make them your friend.
Yes, yes, you do.
The last thing I'll say about this too is, let's say it's premium freight. What's the cost of expediting your materials all over the country? Now, we'd be tempted to say to accounting, hey, I need every invoice for every extra truck that went all over the country. Now, that's a lot of work. You want to use simplifying assumptions wherever you can. So if you have countries all over the customers all over the United States, and you're transporting all of this material around, yes, the shipping to each of those cities will have a slightly different cost. But it would be hugely painful to try to get to accurate costing to within a few dollars for every city in the United States. So for the example of shipping, expedite, I tell my clients, choose a nominal value. Say it's $500. The average cost of sending a truckload of stuff to my customer is $500, or it's $1,000. Pick a number, and then just apply that number as a factor. Right? Every time I have to, ship something twice, it costs me $1,000. I just throw the number at it. It's simple, it's reasonable. It's simple, it's reasonable, and it helps to make sure that you're not underestimating those costs.
I would add to that, Dennis, just one thought process, which is, you mentioned it, you have to get finance to say, yes, I believe in that number. Okay, so if to start out, Amir, I would say, go to them first. Do you have this number? Okay, how do you derive it? Ask them for their model, understand what they're using and how they're using it. Then take that to the floor and balance that against maybe what the reality is. Okay, you will almost certainly find some gaps. Those gaps are where you can help provide value in their model. And then you can start to work with finance to say, hey, let's adjust the way that we look at these to reflect a more fuller picture, the accurate, true cost of quality, and gain consensus along the way. Bring your finance person to the floor. Show them, this is what I'm talking about. When I'm saying this is what's actually happening. Because a lot of times when you live your life in a spreadsheet, as many financial folks can do, right? They lack the context for that data. And so pulling them down to the floor builds that teamwork that you guys can both sort of be on the same side of the table, working proactively on increasing productivity, decreasing these wastes, and so forth. So, well,
thank you.
Let's bring us to the end. Any final words?
No, thank you for adding that. I don't think I could have said it better myself. Are there any more questions, or are we sort of finished?
That's it. Yeah, we got just a couple minutes left. So I was just going to mention a couple of things coming up here. SafetyChain.com. Of course, you can go. We do have the Understand SPC Fundamentals. Of course, we don't have the right date on there. Today is April 5th, I think, if that's still accurate. But we do also have the SPC coming up as well. So Dennis, I wanted to flash up on your screen really quick. If you have any questions, this has really been super helpful. Dennis is the expert here, and you know, sometimes tackling these projects, whether you started or you're looking at going into this or something like this, sometimes you really just need a partner to help you along, and this is where Dennis specializes. You need someone like Dennis to help guide you through this process. So I very much recommend reaching out to Dennis, contacting him for more information. And then we will be following up with everyone on the line today with the slides and the video and all that good stuff to consume at your leisure after this. So with that, I do want to wrap it up for today. I appreciate everyone's time. Again, it's busy, so I appreciate everyone taking some time today to spend with us. And that will end it for us on Beyond Compliance. I appreciate everyone, and go take care.